Hello everyone. In this video, we're going to take a look at the solution to this problem. What are the last two digits of the number which is formed by multiplying all the odd numbers from 1 to 1,000,000? So the first thing we're going to do is we're going to compute the product of a sequence of odd numbers and then compute its remainder when we divide by 11. So if we compute the product up to 15 or 17, we end up with 25 mod 100. And if we go up to 19 or 21, we end up with 75 mod 100. And what we're going to do now is show that we end up in a cycling pattern between 25 and 75. And the way we're going to do that is we're going to assume that we have, that if we start with 25 mod 100, and then multiply by two successive odd numbers, we end up at 75 mod 100, and vice versa. If we start with 75 mod 100 and multiply by two successive odd numbers, we end up with 25 mod 100. So let's start with 25. So any two sequential odd numbers can be written as 2n plus 1 and 2n plus 3 for some value of n. And if we expand this, we see that we end up with something which is equal to 75 mod 100. So now let's take the other assumption. Suppose 75 is multiplied by two sequential odd numbers. So again, any two sequential odd numbers can be written as 2n plus 1 and 2n plus 3 for some value of n. And again, we end up with something which is equal to 25 mod 100. So this means that if our product up to some point is equal to 25 mod 100, then by multiplying by the next two odd numbers, we end up with 75 mod 100, and we keep flipping back and forth between 25 and 75 for each two odd numbers that we multiply. So what we have up to this point, we computed these products up to where the largest odd number is given in the left column and the resulting last two digits of the product is given in the right column. We could continue this column or this mapping all the way down to 999,999, but because we know that this pattern is going to continue alternating between 25 and 75, really what we need to do is find which of these numbers differs from 999,999 by a multiple of 8, and those will have the same last two digits in the product. So just some simple computations shows that 15 differs by 999,999 by a multiple of 8, and so the product of all the odd numbers up to and including this is going to have the same last two digits as 15. And so, namely, the answer is 25. If you'd like to see how I came to this solution, check the process video, which is linked here. Thanks for watching.